get those addresses. It actually received it. We'll take a look at this today a little bit from the router. Well, not really from the router. Okay. What the router did was it sent me something. We're going to talk more about this. It sent something called a router advertisement message. This is very cool. It basically, in this router advertisement message, it says, first of all you IPv6 devices on this network, I am a router. I am your default gateway, or I can be your default gateway. And here's my address. And it actually gives the address that the interface that this router advertisement message went out on. Now, what that address is actually a linked local address. Okay, we'll see that a little later. But also what it says, hey, in this case here, my router is advertising this, and this is at school here, and it's saying, this is the network that you're on. Okay. So it's saying, this is the network that you're on. And it's saying, create your own host portion. So my computer actually created this. Okay, so it gave me a 64-bit, so this is a /64, 64/64 prefix. This is the network, okay? We talked a little bit about that last time, okay? A little bit more about it today, okay? This is the global routing prefix here, how the internet sees Cabrillo, and this is the subnet that we're talking about. Okay, this is the subnet here at that I'm on at, well, what is that? Cabrillo. This here is my host portion known as the interface portion. Now my computer says I'm going to create two of these. I'm going to create one that's temporary, one that I call secure. Anytime my computer initiates conversation, initiates communications with a server, okay? So I'm acting as the client. Okay. The address it's going to use is this one here with this host portion. Okay. Now this is temporary. We'll talk more about this later. The temporary means this is going to change every so often. We'll talk about that later, maybe about once a week. Okay. It can change more often if you want, less often if you want. Okay. But why is that a good thing? We want this to change because this is 64 bits. It's 1 in 18 quintillion. If it never changed, I could be tracked from network to network, no matter what network I'm on. If this never changed, people would go, I recognize that interface ID. You've been there, that network. Doesn't matter what network you've been on. If this never changes, chances are it's probably unique. It's probably you. So for privacy reasons, we want this to change. Okay. That's why when we initiate communications, okay, we're going to use this one. Okay. So it changes every so often. This one here is more permanent. Sometimes even called a permanent address. Whoops, I didn't mean to put it there. This one here. Okay. Sometimes called a permanent IPv6 address. That means if somebody's trying to reach me from the outside world, this is an address that they can use if I open it up on my firewall. Okay, so that's why we're seeing two global unicast addresses here. All right. So when I look at it in Windows, you may see something like this: IPv6 address, temporary. Now here I've got two permanent addresses. We'll talk about that a little later as well. Okay, let's get into the global unicast address, what it is. All right, so global unicast address. So it's going to begin with a 2 or a 3. Okay? And that's what we saw on the examples previously. Okay, those addresses began with a 2. These are globally unique, globally routable addresses, similar to what we think of in the world of IPv4 as a public IPv4 address. Now, this address here, you're going to see me use it a lot, like even right here. Okay, this is reserved for documentation. Okay, that means anybody can use this address. It's not a real public address. It's kind of a best, not only best practice, but good practice that we shouldn't use. And I sometimes do, but I use my own at least. Public IP addresses, either IPv4 or IPv6, that belong to somebody else. Okay. Now, one of the things when we talk about a network address, okay, we have all zeros at the end, just like an IPv4, all zeros in the host portion. Remember that double colon, all zeros? So that's what we have here. Actually, this here is showing, okay, /64, by far the most common. This would be a host prefix. So here's the network portion. So 1, 2, 3, 4 hextets, each at 16 bits. So 16 plus 16 plus 16 plus 16 is, 64, which leaves another 64 bits for the host portion. Now, looking at this, by the way, we know that this is actually 4 hextets. This last hextet, if we write it out, is 0, 1, 0, 0 in hex. This is all zeros. So we know that this is the 8th hextet, and these 5, 6, and 7 are all zeros. Here we have the prefix. Very easy. Again, the first 4 is the prefix, the network prefix, and then it's all zeros at the end. Okay. Here's a bizarre fact. Did you know that, you have 18 quintillion possibilities, right? You can actually use the all zeros for a host address and the all Fs, okay, all 1 bits for a host address, unlike IPv4. Now, don't use this. This is usually means an anycast address. So I would not use this. And this is just going to confuse people as a broadcast. Perhaps maybe confuse people. We don't have broadcasts in IPv6. We use multicast for everything. We'll be talking more about that. Okay, the global routing, the global unicast address. Okay, so in IPv6, we talked about this previously. We have a global routing prefix, subnet ID, and interface ID. Okay. Let's see, give me 1 second here. I want to make sure that I know I did talk about that, right? Give me 1 second. Sorry about this. I'm going to pause the recording here.
Recording stopped.
I want to make sure I did cover something. Sorry about this. Make sure I did cover that. Yes. Okay. Yeah, I wanted to make sure I talked about this already, and I did, so that's a good thing. And we are going to get into some of these other addresses here shortly. All right. So let me go back to this. Sorry, just kind of give you a little bit more information here. Okay, so the global unicast address, okay, the range is from a 2000 to 3 LS. Well, how did they actually get that range? What they mean is the first 3 bits is 001. So we get a 2 by 0010 or 0011. That's how you get that 2 or 3 in that first hextet. And What this means when we see a /3, that means that's all we care about in the, we only care about those first 3 bits in that first hextet. So we're only looking at the first 3 bits have to be 001. Now, why is that a 2? Because you're looking at the whole, that's hexadecimal. So 0010 is a 2, but what has to match is to be a global unicast address is 001, which means this could be a 0 or a 1. I know it's kind of weird. Okay, this is 1/8 of the total IPv6 global unicast, or the total IPv6 address space. We're only using 1/8. Okay, very little. Okay, so we looked at the parts of an IPv4 address, right? Okay, we know in IPv4 what a pain this is, because subnetting was an afterthought. Okay, it was an afterthought in IPv4. Okay, what that means is when we want to subnet, we borrowed bits from the host portion to create subnets. So once again, if we have, just make this real simple. If I have 100 apples, okay, I can have 1 barrel of 100 apples. But if I want to divide it up, I can divide it up by taking that 100 apples and dividing it up into 10 baskets of 10 apples each, or however I want to do it. But that's how I have to subnet. In IPv6, subnetting was not an afterthought. Okay, subnetting actually in IPv6 was part of the initial IPv6 addressing structure for a global unicast address. So one thing is, they said, okay, the typical interface ID, we're going to allow 64 bits. We're going to see the vast majority on very few occasions. Okay, you're going to do anything within your network other than /64s. It makes networking addressing real easy and subnetting really easy. So /64. So we'll talk more about that in a moment, but that's how many hosts we're going to have for every one of our networks. Okay. Global routing prefix. This is how the internet sees us. Okay. So this is our global routing prefix. This then, between the global routing prefix and the interface ID is what we can use for a subnet ID. So this leaves for a interface ID of 64 bits. This means we can have 18 quintillion devices per subnet. Okay, it's not a waste. We've got 340 undecillion addresses. Okay, it's all about making the organization, the addressing easy for us. Okay, so we don't have to worry about, okay, how many addresses do I need? It's not even a worry. Okay, and it makes it really easy to look at what is your global routing prefix, what is your subnet ID, what is your interface ID. Okay, I'll talk about Anycast a little later. All right, so I talked a little bit about this already, so I'm going to too much here. Okay, let me kind of get past the subnetting. We don't need to get into CIDR and stuff like that, but let me just talk again about, let's use this here. That's what I want to get to. All right, so the global routing prefix. Let's take a look. This is Cabrillo College. Okay, so Cabrillo College, I showed this in my CIS 81 class. Okay, so this is what we looked at actually yesterday, wasn't it? This is the global routing prefix that I received at Cabrillo College. Okay, we saw that earlier. Matter of fact, I've got it here. If we like, it's not easy to see here, unfortunately, with the text edit. Got all these red lines here. But anyway, this is when I do IF config at Cabrillo. This is my global routing prefix. This is how the internet sees all of Cabrillo. This is the subnet that I can be on, that I was on when I did this. Let's take a look. Yep, that's the subnet. Okay. And for those of you who may not be familiar with Cabrillo, this is actually one of the room numbers. So the subnet I'm on, I made the subnet. I said this. Let me talk a little bit about this here. So we talk about subnetting, it's really easy. You can use any hexadecimal digits. I'm going to show you a really cool tool to use as well. Use any hexadecimal digits from 4 zeros to 4 Fs. So what I told the campus, our IT department, I said this F, when you ever see an F here in a subnet ID, this belongs to CIS department. This is one of ours. Okay. And I just kind of chose that because it's the last hexadecimal digit. Thought, yeah, we'll take the end here. 828 is one of our room numbers, classroom numbers. Or in my office, I'm on that subnet. Could have my own subnet if I wanted to, but now let's make it easy. Okay, this is the interface portion. So this is Cabrillo College. We have what's called our global routing prefix is a /48, meaning the internet sees us as this address, 2607 F380 80F /48. Means the first 48 bits, hey, that's you, Cabrillo College. Okay. So anything after these 48 bits belongs to you, Cabrillo, and I send it to you. We can have 65,536 subnets, each with 18 quintillion devices. Now let me show you another real example here. This is actually UC Santa Cruz. Okay. They actually have a /32. So the first 32 bits, 16 plus 16, this is how the internet sees UCSC. Okay, so anything beginning with these first 8 hexadecimal digits, they send it to UCSC. And once it gets at UCSC, okay, well, UCSC, again, these are all, by the way, these are actually all /64 subnets internally, /64. /64. So internally, we, both Cabrillo, UCSC, and everybody else says all of this is the network portion once it gets in our network because we are subnetted. Okay. All right, so what does that mean for UCSC? Well, they can have 32 bits, remember 4 bits each for subnets. That gives them 4.29 billion subnets, each one with 18 quintillion devices. Now, it's not about, hey, is this overkill? Is this too much? No, that's not what this is about. It's not about conserving addresses. We don't care. This is about being able to use hexadecimal digits to easily recognize your subnets. It's to be able to do proper and easy address planning. Okay. You know, UCSC may use some of these at the beginning for their different campuses that they have. Okay, and then something else for the departments and stuff. So you can actually create a hierarchy. Matter of fact, if you're really interested in this, I'm at UCSC here. I don't have the book, but let me show you the book by Tom Coffeen. I'm going to just bring it up right here on Amazon and show you. So this is a book Tom Coffeen wrote. Actually, just say it's not a thick book. It's fairly short on designing an address plan using IPv6, some of the things that you can think of, whether you're an ISP or a smaller organization. All right. This here is Google. They have several /32s, and I'm assuming this is a /32. I really don't know. There's some ways I could kind of figure out what they got, but you know, it's all kind of speculative on my part. Okay, but they have probably several /32s. They probably have initially got something, maybe even something like a could even be a /16 or something. This here is Facebook. So look how clever they are. Okay, what they did is, and I'm assuming within their own networks, they're using /64s. So part of their server address, look how they start their server addresses. I love this. Okay. They say for the interface portion, the host portion, 64 bits. Here's the first 32 bits, Facebook. So you know you're on a Facebook server. And then we have another, so that's 32 bits. Another 32 bits here. So does that limit them to how many servers they can have? No. 4.29 billion possibilities. And let's think of this if this was a subnet. Let's just assume that's a subnet. They had 4.29 billion subnets. Okay. For each one of those subnets, they can still have 4.29 billion hosts. So there's no limit. I mean, it's about making things recognizable and easy to use, to recognize. Even your host addresses. Okay. And you can do this. Even using DHCP, you can assign things so they actually get this as the first part of their host address. We haven't talked about that in the 81 yet, but that kind of thing is not easy to do in IPv4. It's literally, almost impossible. But IPv6, we can do these things. We can have our DHCP server. Yes, I talked about router advertisement earlier, but if you want to assign addresses via DHCP or even via, statically or however you want to do it, and this is probably this was, I'm sure, a static address, okay, as a server. They said, hey, we're going to create our server addresses, let's give them this, and then we'll statically configure this part as well. Okay, very cool, very cool. Okay, this address here, this poor soul here, only has a /64. This is me at home. This is actually when I was in Carmel, San Jose. I still use Comcast. I still have native IPv6, but I have one /64 network. So I don't get the subnet. I've told this story in my other classes. I did call Comcast early on when I got my IPv6 address years ago, my network address. I got a whole network, public, to myself. This is globally route. This is how the route internet, reaches. This is what they see when I go to Netflix, Google, whoever. This is what they're seeing, and all of this. But I asked them. I said, shouldn't I be getting some subnet? Be allowed to subnet? Shouldn't you just give me a prefix that's not a /64, maybe a /52 or 56, something that allows me to subnet? They say, what? I'm like, okay, never mind. Okay, so again, the global routing prefix, this really determines how many subnets you can have. So when you get a global routing prefix, you're not that really concerned about how many hosts per network. You're going to use /64s. And there's a reason why /64, besides one reason it fits nicely on a /32-bit boundary or /30 or 64-bit boundary. That actually does help a little bit. Because processing can happen easily in chunks of 32 and 64 with 64-bit processors. But, okay, we'll see what one of the advantages of this here is in a moment. Okay, I'm going to lead us into some other things we're going to be looking at a little later, but we'll take a look today. This is going to be our host. We're going to have 64 bits per subnet, per network. Okay. That's kind of a given. Okay. Don't do otherwise. Okay. This is how our network is going to look internally. So we're going to use /64 networks. Now, part of this is going to be how the internet sees us. Part of this is our subnet. What that determines that is what global routing prefix we received from our internet service provider. So if I received a /32 from our internet service provider like UCSC got, then they get to have 32 bits for their subnet ID. They can have 4.29 billion subnets. That's as many subnets as there are IPv4 addresses. And each one of those subnets, 18 quintillion hosts. Okay, if they have /36, /40, maybe a /44. By the way, this is not uncommon to get a 40, to get a /40 or 44 anymore. Why is that? Because ISP says, we have plenty of addresses. Okay. You may want to use these first two hextets for different sites. Okay. 4 and 4, what's that? That gives me what? 16 possibilities? No, that's just 16 possibilities. One. It's 4 and 4. That gives me 256 possibilities. What this does is says, let me go to 16 here, make it a little easier. Why is that? Packet traces give me a little issue here. Let's use this. 0 through F, right? I can make this for all my different sites. If I had, say, 5 different sites, if I had 5 different sites, corporate, branch office, whatever, I could give each one of these a letter, a hexadecimal digit, 0 through F, and assign it to them. And then internally, they can use these to create subnets. Not that they, how many subnets? 65,000 subnets. Not that every one of these, let me kind of do it like this here. This could be 1, 2, 3, and then we go down to A, B, all the way to F. I'm going to have 16 possibilities. Let's say these were my branch offices. And then each one of those can have everything from 4 zeros. So this will in a moment, all the way, make it uppercase here, to 4S for subnets. So each one of these subnets, subnet 3, could have these internally. Okay, so we have 3000, 3001, and all of that. So think of each one of these as like a branch office. Okay. Now, does this branch office need 65,536 subnets? No, but that's not what it's about. It's about how we can use these hexadecimal digits to, at that office, to break it down further, to say, maybe we want to do it based on location for this here, maybe the building, maybe the function, whatever it might be, break it down. So we can easily recognize what that subnet is, okay? We don't have to get into the bit level like we do with IPv4. Okay. And I just want to mention, by the way, once again, Tom Coffeen's book, if you're really interested, and there's plenty of other stuff on the internet there. Wow, it's down 41% off, $20 for that book. That's pretty good. Okay, it's been out for a while. Yes, Pamela.
Rick, thanks. I'm just wondering, when you said earlier in the lecture about we really only care about the first 3 bits that are 2 and 3, I'm trying to connect the dots as to all of this other information and our emphasis on caring about the first 3 bits. Am I missing something?
No. No, good question. So this is why here, for a global routing prefix, this is only going to be one of 2 numbers, and that's it. Okay, that's all that's assigned.
Okay, just for global routing.
Yeah, so okay. Let me back up here and explain that a little bit better. Okay. What this means is IANA allocated the first 3 bits, 001. They said, we don't need all this. We don't want to see, we want to, and there's a reason for this, keeping everything to a 2 or a 3. We don't need addresses. If they didn't care, then anything, the first number could be anything from a 0 to an F. And so you'd see all kinds of stuff out there. And just make your routing tables look more complicated. They said, let's make this really simple. And it also helps with summarization. And talk about that in later courses. That's where you take a whole bunch of networks and summarize it as a single network. But this says, you're gonna see everything in your IP routing tables as a 2 or a 3. So you don't see all these other hexadecimal digits. Okay. So that's all it's for. It's just says, we don't need all of this space right now.
Okay, thank you.
So good question. All right, some of these other global routing, is that where I left off? Yes. Okay, so some of these other global routing prefixes. Okay. /48. This is what Cabrillo got. Okay. This is what we saw in Cabrillo's address. It's my Cabrillo. Here we go. Sorry about all those red lines there. It's my text editor. So this is what Cabrillo got. So anything the internet sees, they see that as Cabrillo. I'm going to show you something here. Show you what I mean. So look at this. Go back here. So this is what's known as sometimes a who is lookup tool. This is ICANN. And by the way, all I did was this. Who is? I Googled who is, and there's several out there. I'm using this one here by ICANN. Okay, they're part of, they're the organization that does all the address, actually the operational part of IANA, of allocating addresses. But you can use any of these. There's a lot of good ones out there. So let me go to ICANN. What I'm going to do is put in my Cabrillo address here. So who owns this? Matter of fact, I could put in the whole address if I wanted to. Okay. And I said, look at this up. It says, oh, wait a minute, it's giving me some information on this address. Isn't this cool? Okay, so this is my address. Like, well, who owns this address? Who are you? Oh, it belongs to Cabrillo Community College. Okay, this is the regional internet registry of who assigned it, Aaron, in U.S. Canada. This is the address range Cabrillo has. So you can see it's the /48, meaning everything from this, all zeros, to this, all Fs. Cabrillo, that's yours. This is how the internet's going to see you. Here's what else we got here. This is, so if you have a problem with this address, you're getting some spam or got some kind of issue, this is who to contact. Okay. This is Scenic. So Scenic is for any kind of abuse. So this is the register. So we read, me and somebody actually registered this address, or we asked for it. We don't actually own the address. We got it from we didn't get it from Aaron. So if you remember, okay, we have, let me see if I can bring this up here. We have 5 regional internet registries. Let me see if I can bring up one of these easily so you can see it, the graphic. Okay, so we have 5 regional internet registries. I was hoping you'd be better than that there. That's not my browser and everything. Aaron. Okay, IANA gives the addresses to Aaron. Aaron is the regional internet for US and Canada. Okay. Aaron gave the address to, so Scenic asked for IPv4 and IPv6 addresses. Okay, they're the ISP for the K-20 school system. Cabrillo, we got our address from Scenic. Scenic actually controls this address. It's under their name. Okay, that's the ISP. Okay, but we're the registrant, meaning this address space is for Cabrillo College. Show you another one. Let me show you another one while we're here. Does this help, by the way? Show you this stuff? Okay, good. Let me show you my home address. And by the way, this works for IPv4 as well, not just for IPv6. How about this? This is my home one right now. Now it should say Rick Graziani, right? No, it's not going to say. I don't own this. Okay, this doesn't belong to me. Okay, let's look it up. Oh, wait a minute. Who has? Look at this. Wow, they got a /32. Is that Rick? They gave Rick a /32? I don't think so. This is who they gave it to. Comcast. Xfinity. It's one of theirs. And who gave it to Comcast? Aaron, the regional internet registry for US and Canada. Okay. And by the way, you can do the same thing. Let's do it for IPv4 here. It's going to show. This is where I am right now. You can do what's my IP address, get your IPv4 address, and you can do the same thing. You can put it right here, look it up, and it tells you who has that, who it belongs to, okay? So it works for both IPv4 and IPv6. And again, that's the who is. Kind of cool, and it does other things as well. You can, so, all right, let's get through this here. So again, showed you my house here, my network. This is actually mine when I was in Carmel. I'm a host on that network. So this is my phone. Okay, this is my Wi-Fi. Okay, yes, running IPv6. This is my provider, Verizon. So IPv6. Yes, IPv4 as well, but also IPv6. Okay, so what this means is for many sites, when I'm accessing Google, even Cabrillo, because Cabrillo, when you go to cabrillo.edu, okay, when you go to Cabrillo College, okay, you're not, this server no longer, hasn't for years existed at Cabrillo. It used to, no more. It now, this is hosted in a cloud provider, actually Amazon Web Services. Amazon Web Services, yes, they do IPv6. So all these sites here, if I'm running both IPv4 and IPv6 at school or at home, it's like here, I'm at home. Okay, if I can first, my operating system will look and say, okay, do I have the domain, the IP address for when I type in www.cabrillo.edu? Okay, if I don't, my computer sends a DNS query. Hey, DNS server, I need the IP address for cabrillo.edu. The server responds, and if it gives me only an IPv4 address, then I'll just try IPv4. But if it also gives me an IPv6 address, then my computer goes, hey, I'm running IPv6. You gave me Cabrillo College's IP address, both IPv6 and IPv4. Hey, let me try connecting IPv6. And if we can connect IPv6, if that works, then we'll just continue IPv6. Okay. If not, then we'll do IPv4, but IPv6 is preferred in the operating system. Am I not? Oh, darn it, I'm not recording.
Recording in progress.
Wasn't recording. Sorry about that. The good news is everything I've covered up until this point, and I'll stay on, I'll have to do a little extra recording at the end of, I'll have to do a second recording. I think I paused at some point. I'll have to look. And, because I was, trying to find something. And, so anyway, I'll come back to it. We covered a few things, actually, same things we covered in IPv and CIS 81, but I showed some kind of cool stuff. So I'll add that to the end. Sorry. All right. All right. Let me get past this again. Okay. So yes, I'll communicate both. I communicate over IPv6. No network address translation. Okay. My source address, they see me as my IPv6 address. They send it back to my IPv6 address. No network address translation. Now, if there's a site I'm trying to get to that's IPv4 only, then my computer will use IPv4. What would be an example of that? Yeah, Twitter, now called X. Okay, they are IPv4 only. Okay. But even Zoom that we're doing right now, if I was at school or at home, it would be over IPv6. I'm at UCSC right now, although they're planning on going to IPv6, they are doing, they are right now just IPv4, but they are moving towards IPv6 or dual stack, doing both. Okay, we saw this already. So again, the subname, let's talk a little bit about subname. And then I'll do a little bit with packet tracer. I'm kicking myself right now for not recording. Okay, Cabrillo College, we got a /48 from Scenic. Remember? So that's what I was showing earlier. Okay, so again, if I take a look at my IPv6 address, so this is my IPv6 address at school. Okay, and I'm just gonna copy that in here to this Whois lookup tool. And we see that belongs to Cabrillo College. And Cabrillo College got that, a /48. Okay, meaning that they own everything from this, all zeros, to this 48 bits, and then all S. This is 64 bits. This is 64 bits, host portion. Okay. So we got that address, as I mentioned earlier, from Scenic, our ISP, and they got it from Aaron, the Regional Internet Registry. All right, so what did Cabrillo do with this? Okay. Well, we got the /48. Okay. There's our /48. We've made subnets, or Rick made some subnets. Okay. So, for example, this is the subnet that I'm on in my office. It's that easy. I'm hopefully, are you beginning to see how easy this is? If you know your organization got a /48, that's what you're always going to see. And all you've got to do is change this. Now, the host portion looks a little scary, but how many times do I care about what my host IP address is? Or how much does IT care? There are host IP addresses we do care about. Okay, we'll talk about that in a moment. Is this making sense? How are we doing? I'm feeling better after I'm recording again. All right. So all you have to do, if you have a /48, 314-123 global routing prefix, 1 hextet is your subnet, and the next 4 is your host portion. Show you kind of a cool little tool here. Let me bring it up. This is called IPv6 Gen. Let me show you where you can get that. So if you just Google IPv6 Gen, you can get it from GitHub, you could download from some different places, but probably this is the best place to get it. But it generates IPv6 prefixes for you. So for example, if I run this program and I give it, says, this is my /48, give me /60, show me the /64 subnets. What it's going to do is show all the /64 subnets. Not in red, but it goes through all the subnets. Oops, this packet tracer. I got packet tracer running in the background here, and it keeps on grabbing my active screen. Okay, let me see if I can bring this up here. Let's do another example. So, IPv6 gen.pl. And let's say, let's use Cabrillo. Okay, let me grab Cabrillo address. Okay. So Cabrillo okay. This is our, we're /48. Okay. And same thing. I want to see this, all the subnets we can have at Cabrillo. It's going to go for a long time. These are all the subnets. All the subnets. We use any of these subnets. They all have 18 quintillion hosts. But just think how we can arrange things, how we can organize things. Okay. If, well, let me use another example here. Okay. Let's say, let me take my home address here. Show you another example of how to use this. Nope, you just type it in. 2601 6. Sorry about that. That's my packet tracer. 9E02. This is what I got from Comcast. Okay. 94B0. Now this, they gave me a /64. Hey, but what if they would have given me some subnets? Okay. Maybe not a /48, but maybe, what if they did this? Let's figure this out. 48, let's say they gave me up to here. Okay, and then that can use this for subnets. So what is that? Let's do this. 16, 32, 48 plus 4 is 48 plus 4 is 52, plus another 2, 56. Now we got to put the trailing zeros there just to denote that this is 9, 4, and then it's, there's 2 zeros after. So this is a /56. Oops. And show me the 64-bit. Show me subnets. If I want to subnet that as 60, show me all my /64 subnets I can have internally. So this is a little easier to see. Oh, oops. Did I go too far? I did, didn't I? Ah, there we go. This is where, should put this in a new terminal. All right. So this is saying, Rick, this is what Comcast gave you. First 56 bits, that belongs to us, Comcast. But Rick, we're going to let you have a subnet ID if you want. Oh, yeah, I want. I can create all these subnets at my house, 0001 all the way. Okay. I can have 8 bits for subnets. That's 256 subnets I can have from 00FF. And that's kind of where things are headed. All right, let's, what I want to do next is take a short break. And now let me go through this real quick. Then we'll take a short break because I want to show it on Packet Tracer. That's what's beeping at me constantly. Okay, so the internet may see me, so what happens when an ISP gets an IP address like this? Darn new Packet Tracer. Okay, so the internet gets this packet. Okay, let's say I'm 2001 DB8 Cafe, 48 bits. That belongs to me. So they're going to send anything beginning with 2001 DB8 Cafe to me. But internally, I can be subnetted any way I want. Well, I'm going to use /64s. So I'm going to use that 4th hextet internally, and now route this packet to whatever my subnet is. So here's an example here. Okay, a packet coming to my computer. This is a real example here. My computer at my office at Cabrillo. This is the destination IP address. The internet routes everything with those first 48 bits. This is what it looks like in the routing tables. It says everything with /48, we're routing from one hop router to the next hop router, eventually to a scenic router located at Cabrillo, and then Cabrillo's router, and it gets to Cabrillo. Okay. And then once it arrives at Cabrillo, we see everything as /64 subnets. Okay, says, oh, well, this is not just us, this is specifically the subnet F828. And let's send that to Rick's office. UCSC, if they were implementing IPv6 internally, it'd be anything beginning with these first 32 bits. They would say, hey, anything beginning with those 32 bits, that we're routing our way to UCSC. So it gets to UCSC. Okay, and then once it received at UCSC, anything belonging with these first 32 bits, first 2 hextets, hey, that belongs to UCSC. Okay, now it's at UCSC's network. Says, yeah, now we're subnet with all these /64 networks, and we can have a lot of them. Okay, and now we can get it specifically to Rick's office at UCSC, the subnet that he belongs to. Okay. My house, it's not that complicated. So the internet sees me as this /64. They actually, and I'll give me a moment here, I'm going to talk about this. So they actually see, the internet doesn't see this whole prefix, 64 bits. This is what we call summarization. What they see is this, okay, /26. Okay, so 16 plus 4 plus 4. They say anything beginning with this belongs to Comcast. Let's get it And that's all we care. This is called summarization. So routing tables in the internet only have to have this, and then they get it to Comcast, the cloud within their network. So everybody in the everybody else just says, we'll get it to Comcast with anything beginning with these first 26 bits, these first 6 hexadecimal digits. Now, once it's in Comcast's network, Comcast sees it as, oh, okay, you're in my network now. You got it to me. Because all you cared about was you knew anything beginning with these first 6 hexadecimal digits is mine, is Comcast. So you didn't have what that does is that means that all these ISPs out there, all these autonomous systems, they don't have to keep all these different 2601642, all these different network addresses. No, they just say all they're looking at is all we care about is this, the first. Let me a little bit better. They say all we care about is this. Okay, and we know that anything beginning with that, we get it to Comcast's network and a Comcast router. And once the Comcast router gets it, within Comcast, it says, yeah, we'll take it from here. You got it to us because you knew about this is us. Internally, yeah, we know how to get that. This one here, oh, yeah, we know that guy. That's Rick. Let's get that to his house. Then it gets to my house, and I don't have any subnets, so it just goes right to my computer. Does that make sense? It's called route summarization. We talk about this in a little bit in CIS 82 and CIS 83. This is what keeps internet routing tables smaller. Okay. A ISP doesn't have to know all the individual networks at Comcast, IPv4 or IPv6. It just says, these are the ones that belong to you. At the beginning, and we know you're subnetted inside, you've divided this up. We're just going to get these first, whatever, IPv4, IPv6, the first beginning part of the address to you, and then you take it from there. Okay. Let's do this. Let's remind Rick to start the recording, but let's take a quick 5 minutes. And boy, I'm losing power here. Battery not charging. Okay, I gotta see what the problem is here. Okay, let's one of those mornings. Okay, let's take a 5-minute break.
Recording stopped.